share it. Right, welcome. Now that we're recording, let me share a link with you where I have made a small little website consolidating the materials for this tutorial or for this workshop. Basically, just some general information about the course, a link to the Eventbrite page, any updates, anything that comes up today, we'll put it on this little site as well, and the slides for what I'll be doing. Juan has his own slides, but his part is mainly practical. So let me share my screen. And let me know if you can see it.
We can.
Cool. So yeah, this is just the little course website, some installation instructions. This you should have received over email, and let me find my slides. So this is just my presentation for right now. If you open the slides, you can follow along. Otherwise, you can just look at the screen sharing that I'm doing. All right, so let's get started. This is the workshop Coding with AI in RStudio. This is one of two workshops in LatinR related to working with large language models. This is also one of two workshops in LatinR that are being taught in English to encourage more participation and just because. Otherwise, we are happy though to take questions in Spanish. Is that okay, Juan?
Yeah, absolutely.
All right, so let's get started. And the first thing I'll do is just make some introductions for us. So Juan, without your permission, I put you down there with that photo and this brief description, but if you want to introduce yourself, please do.
Yeah, I'm Juan Cruz Rodriguez. Thanks for my presentation, Luis. I'm a software engineer, over 10 years working with R. I've been working on startups, software engineering for many production-ready sites. So that's me mainly.
Okay, so that's I've linked on the slides both of our GitHubs, both of our personal sites. You can check those out. And I'll introduce myself. I'm Luis. I'm a biologist, though. I work with mammals and ecology and things like that. But I'm also very interested in working with R and teaching others how to work with R. And sometimes I develop silly packages that I like to share with people. And yeah, so I do have some interest in this topic about coding with AI in R. You'll see that Juan has as well a significant interest in this topic. And before I move on with my slides, let me show you mainly the reason that I'm here today, which is that I have this guide online about large language model tools for R. Let me just open it in the browser and show you. Basically, it's just a quarto book. It's in English and Spanish. I try to update it as much as possible.
It's not showing because you're
I'm
in
about to, change this. Here we go. So this is just a site, basically a summary with reading materials, and I try to collect all the packages and all the relevant tools for working with artificial intelligence and generative AI and LLMs in R. So just packages with a brief description and with my opinion or my thoughts on each one. And I try to keep this updated every month. I have a big update coming up for everything that happened in November. And as I was saying there, The site is in both English and Spanish. So I feel like that's pretty cool because there aren't that many resources for this in Spanish. So this is just the site I wanted to mention, and just to show that I'm interested in the topic and that I try to at least be aware of things that we can do. Even though I don't use all of these tools or whatever, I'm trying to keep up with the developments in the field. And this field is moving very fast lately. So this might be a good place to look at. So the tools that we'll show you today, they should all be listed here in one form or another, but just wanted to let you know about the guide. So I don't know if someone linked it in the chat, otherwise I'll put it myself as well. And all right, go back to my slides. So as a very brief, quick start, we will do some practical activities today. So again, a reminder of the packages that we might end up using, or that at least that we'll be demonstrating. And if you want, you can follow along. So we have these particular packages. These live on CRAN. For the data set, we'll be working with Simpsons, data from the Simpsons that we installed from GitHub, from one of Juan's repositories. And in a few minutes, I'll give you on the chat, I'll share an API key with you all. Actually, let me do that. No, I'll do it in a few minutes. If we want to use some models to, we're going to identify ourselves with a particular model provider, in this case, OpenAI. I'll share a key with you. This will just be active for today. And make sure to make a note of this. Basically, in R, we'll just use this function, sys.setEmp, to store the API key, this one for today, in the environment variables. And that way we can work with OpenAI models for some of the demonstrations. All right. But let me do some background and a little bit of theory first, in case anyone's not very familiar with this. So because you signed up to this workshop, this tutorial, I'm assuming you are interested in large language models and working with them for coding, but just a few quick definitions. So basically, what do language models do? They predict and generate text using probabilities, and specifically estimating the probability of tokens occurring in a given sequence. Now, because I'm mentioning tokens are just basic units of text that these models, they use them to process language. And sometimes they coincide with words, or they just be parts of words, or letters, or numbers, or character sets. And these are the units that we use to basically encode and process language. And these become important when we're dealing with models that have different costs and speeds and limitations, because everything is done and measured in tokens. So I mentioned tokens, I mentioned language models, and basically large language models just add many more parameters, and they've been trained on these very big data sets that enable us to do more complex tasks. So this is a quick example that I always like to do when explaining large language models, which basically is that if we, just as people that know about things and know about the language, if I show you this sentence and I ask you to complete it, actually feel free to answer in the chat. So what would you put in that blank there?
For puppies, we have there.
Puppies. So 3 people say puppies. Anything else? Anything else that would be likely or just sensible to put there? So I have two people saying in the chat puppies. Any other suggestion? Family could be puppy in a singular. I think in previous times I've done this example. People have said pups as well, yeah, babies, things like that. Okay, so it just makes sense. It's just something that would just the more likely probability there, right? We wouldn't really make sense to put chickens there or cats. And I have a quick demonstration on that. So for this, I'm going to run a Shiny app in my RStudio, and I'll just show you what that looks like. And the link is there if you want to go to this repository and maybe clone it and maybe run this app locally, but let me just show you. Once this is up and running. So this is just a Shiny app that uses large language models to complete sentences, but also show the different probabilities for the different tokens. So what I'm going to do is I'm going to copy the sentence. I'm going to paste it in the Shiny app. Complete the sentence. And now I'm chatting with a model. I'm going to put the sentence. After drinking some water, the dog went back to bed to feed her. And I'll just put in a blank. Include the full sentence. And hopefully we get a response back from the model. And the model completed the sentence pretty much like we all did, right? The answer was puppies. And also added a period at the end of the sentence. And we can look at the probabilities. Let me see if I can make this bigger. Can't, but it's showing the different probabilities. So the highest probability token in this case to complete the sentence is puppies with 66%. And then we have a period and just 100% probabilities because this was our input anyway. So basically that's just what models do. They'll draw from probabilistic distribution and just fill in blanks using the most likely tokens to complete something. So seems straightforward. There's a lot of math involved, a lot of computing involved, but basically we can use that to actually get useful things happening, right? So this is just a description I saw recently on the web about large language models, calling them just essentially language calculators that use natural language processing algorithms to interpret prompts and then generate statistically plausible answers. And statistically plausible can be good enough for what we need. So just based on this, on the principles I showed you, ultimately we can use these tools to generate text and translate text between different languages, or maybe rewrite code, debug code, which is one of the focuses here, generate images, generate videos, and the focus today is on coding. Sorry about that. Okay. And just a few quick quotes here from two people that are moving a lot within the AI world online, like a enthusiast, and then also someone that's not very enthusiastic. But both of them, they agree that it is important for us to just have as people the ability to both communicate with machines in plain language, and also just use these tools to automate tedious tasks and just have more time left for doing other productive things. So now we can move on and actually let me discuss basic coding with LLMs, because there's a few things we can do and a few things that this field has moved on to recently. So I don't know if you've seen this. I believe that as users of RStudio, this implementation has been around the longest. And basically, this is autocomplete, where we have our text editor and we write in code, and then a model will read all of our active script and the content of whatever we're editing and suggest like ghost text as we type. And if we like the suggestion, we can keep it and just keep typing. Otherwise, we can dismiss it. And it can be helpful. Sometimes not too helpful. It really depends basically on what we're doing. I don't use this a lot, and I don't use this at all for teaching because it can be very distracting. If you're trying to look at what someone is typing and it's like someone's doing live coding, and then we see all this ghost text appearing and disappearing, or just full sentences being written, and then just it can be very distracting during teaching. This is like one of the a very simple way to use AI when we're coding. And in RStudio, which is the focus or the IDE of focus for today, this we can enable using GitHub Copilot. For that, we would need a Copilot account, and basically we just enable it in the RStudio settings. So that's just one way of coding with LLMs. And then there's two other ways which have a lot of overlap, as we'll see. And the next way is to use chats. So basically, we have a box of text, just like I used just now, where we send prompts, we ask questions, and then we get answers. And usually, with these chats, we can often provide context, like refer to a specific file or multiple files and upload them and have the model read these files, and then we can ask questions about those. And we get answers or we get results, and those we can either just copy and then paste in our console or our open scripts. And with certain tools, we can just make changes directly in our source editor. And these kinds of chats, they're the ones we see the most. We can use them on the web, like we go to on our website and we go to chatgpt.com, or we go to Google Gemini and things like that. We can bring these chats into our IDEs, or we can also basically use our command lines, our terminals, as chat boxes, or just use these chats in apps on our phones or as desktop applications on our computers. Many ways to work with chats. And in a bit of an overlap, sometimes these chats, they have a bit more reach, and we call these agents, and basically it's just we're chatting with models, but these models, they can run code, they can execute code and evaluate code locally in our machines. With our permission, they can also change files, modify existing files, read files, create new files, move things around on our computers. So that's what agents do. And generally, agents will come up with a plan and then follow it and work through it with a certain degree of autonomy. And a few things to be aware of with agents is that, as I mentioned regarding tokens, which is the units of transaction with these models, sometimes they can be very token hungry, and they'll consume a lot of tokens and potentially a lot of money if we're using like an API key and we have a paid plan, and just so much tokens going back and forth that they can be agents. Yeah, they can be very token hungry, sometimes slow. I think it's getting better. And when we're letting um, these agents or agentic models do many things for us at once, in a way, it forces us to assume that the results are correct, although I should still suggest double checking these outputs. And I'll discuss all three of these approaches in the context of RStudio. And with Juan, we'll be working through agent tools, specifically in RStudio. Okay. So I've discussed a few approaches for coding with models, but then we might be asking, like, okay, so you're talking about models, but where are they and who makes them, or how do I get them? And these are just 5 of the, I think last time I checked, there are at least 100 different providers. So just companies or institutions or organizations that they'll train and they'll make models available for other people to use. Many popular models, they live on the cloud. So they're running on the machines for all these different companies. You might know OpenAI that has these the GPT series of models, and this includes ChatGPT that we use on the web. Google has an AI branch that they come up with Gemini models. Anthropic that uses that produce the Claude models, or DeepSeek coming out of China. And if you are a user of GitHub Copilot, they host multiple different models from multiple providers. So ultimately, we choose whatever works for us. But let me mention a few things about these models that are living in the cloud, so on someone else's computer. They're relatively easy to set up. For the most part, we go to one of these websites, we create an account. Sometimes we have to set up billing or maybe pay, but in most cases, these model providers, they'll offer a free tier, a free user account, maybe with some limitations about speed or how much we can use their models per month. But basically, we go there, we create an account, we get an API key, and when we do this, we have access to a lot more computing power than if we're trying to run a model on our personal machines. It can be done, but it's not the focus today. We had a tutorial yesterday in LatinR. Maybe we can look at that recording next month. But basically, with cloud-hosted models, we have access to the latest models and we have access to lots of computing power. A few downsides is that if we get carried away with this, we might up just spending money, and sometimes more money than we'd like to. And also, we can't work with these things offline. We do need internet access. And when we're using these models, we will be sending information to their API over the internet, regardless of whether the connection is encrypted and the privacy settings and reading about how these models and their providers, how they treat our information. So just something to be aware of. And then, so how do we choose models? And a few things we can consider is pricing. So most providers have free tiers, some models as well. Older models tend to be cheaper to use. Newer models are more expensive. The context windows that I want to mention is just the total amount of tokens that a model can work with. That's the context window, and they also vary between different models. And then there's things like speed and the privacy policies for different providers and how fast they are. And this one that I'm highlighting is that not all models are compatible with whatever tool we might choose to be using. So in particular, if we're working with R code, some models are better at writing R code than others, but then this is constantly changing. There are ways, there are benchmarks that people use to test how these models perform at writing and editing our code. I think, but month by month, the best performing ones tend to change. And that's why I think an important one is compatibility. So some providers won't work with whatever we need to use in RStudio, or if you're using the Positron IDE, also created by Posit, then that's also there tend to be a focus on using just a few particular providers over others. But ultimately, we have lots to choose from. And all right, so we're aware of what the models can do and basically more or less how they do it. And we've chosen one. And correct me if this is not at all how you do it, but the traditional workflow, as I often see it, is that we're working with code and we want some help from an AI tool. Basically, we have our RStudio open and we also have a browser open. So we ask the chatbot in the browser, we get a response back, and then we copy the response and then we paste it in R, and then we run whatever code was suggested by the chatbot or by the assistant. And then if it worked, okay. If it didn't work, we share the errors or we share the output with the chat and we elaborate on what we need to do. And then we just repeat until we achieve our task. And sometimes we might introduce errors when we're going back and forth like this. This is a traditional workflow that I see a lot. As part of my current work in my lab, I get to just hang out and help students when they're doing their analysis and their visualization and things like that, almost exclusively in R. And this is the workflow that I see them use. And for the most part, this works, and they can get things done by just asking the chatbot and just moving over, shifting between their RStudio and whatever model they've chosen to work with. Generally, the one I've seen the students in my organization work with is ChatGPT. But that's the traditional workflow, and it works from what I've seen. However, when we're just switching context, like shifting our attention between different tasks or different programs, like I was mentioning, going back and forth between the browser and RStudio, it can just make it can get tiring, and it can make us less productive and less efficient. And also, when we're copying and pasting just bits of code back and forth, we can make mistakes, even just typing mistakes, or forget what we were talking about, or the model will not know what we're talking about. And also, if we're working in this traditional, more traditional workflow, the chatbot in the browser doesn't know what files we have and what the script we're editing has and what's in our environment. So there are tools that we'll be discussing that can just close this gap between our environment and our open script with the chatbot. So this is what the workflow would look like if we're using more context-aware help. We ask the chatbot, not in the browser, but just directly in our IDE, which for today will be RStudio. And then rather than copying and pasting and going back and forth, we just apply the response directly in R. So it's just fewer steps, and it's also less copying and pasting, which brings us to coding with AI directly in RStudio. And these are a few options or a few ways that I've categorized our interactions with AI in RStudio, which is that we can interact with these models in the R console, just running inside RStudio. I have examples for that. We also have the option to use packages that give us add-ins for RStudio, and the add-ins help us interact with LLMs. We also have examples for that today. Even cooler is that we can chat with an assistant that's running inside our studio, typically in the viewer pane. So we have our code, we have our console, but then we can also chat with an assistant running in the viewer pane. So that's why we don't leave our studio to do this. No more shifting back and forth between the browser. And another option that's a bit more complicated and more involved. I myself haven't learned how to do this or how to use this, but I want you to be aware that also there are command line tools that we can install in our at the system level, and they'll just run in the terminal. And because our studio has a terminal, we can also interact with LLMs through these command line tools. Few examples like this, so Google has some applications for this. This thing called Cloud Code that works in the terminal, and if we can get that working, then we can work with that in our studio. But we won't do that today. But just for you to be aware of. So my first quick demonstration and a package that I want to mention is Elmer, which is a package built to bridge R and LLMs. And it's very robust, and it works with most models out there, and it has a big development team. And I like that the outputs, we can use them immediately in R. So basically, I'll do a demonstration with this, and I'll take a second to give you the API key right now. But basically, Elmer works through chat objects. And then so we just create a chat object with whatever provider, and then we interact with that particular object. And that object talks to the model API, and then we can ask things and use these objects to like write functions and run our code and do cool things like that. So give me 1 second to share the OpenAI key with you. I have it somewhere here. And that way we can all use Elmer if we like. So give me 2 seconds. In the meantime, if you have a question, put it in the chat or speak up. Okay, found it. And I'm just going to share this OpenAI key with you. Normally, we don't share keys like that. This one I'll disable at the end of the tutorial. But we can just copy the one from the chat, and we can use them. Let's use the code I showed you earlier about how to get this set up. So basically, we copy this, we replace API key inside the quotes with the one I put in the chat, and then you should have access to this OpenAI models through Elmer and through a few other packages that we'll be using. And this is all courtesy of myself, courtesy of some tokens I was given to try things out just because I developed my little online guide. So take a second to copy that code and just replace it here and run that in your RStudio session if you want. So I'll get back to my Elmer slides. And yeah, Juan has put the whole thing in the chat as well, the whole command. And this will set up that API key as an environment variable just temporarily until you close your R session or restart your R session. You should be able to work with that. So let me do a quick demonstration in RStudio with Elmer. Going to copy the code from my slides. Let me make the text bigger. Bigger. Why not? 2 seconds. All right, that should be big enough. So I'm using this from Elmer. I'm using this function called chat OpenAI because that's the provider that I gave you a key for and that I've already set up in my session. It's telling me that it chose the model called GPT 4.1. Different models have different advantages. We can even use a function from Elmer called models OpenAI. We can see quite a few providers there, but let's see what we have. And basically, this data frame has, let me show you, all these models that are available to us. If we have an API key, their release date, just their name, and some information about their inputs and outputs. Let's just work with whatever was suggested by default, which is GPT 4.1, I believe. Yeah. So now we have this object called my chat. It's telling me that which provider, which model, and at this point we haven't taken any turns interacting with it. We haven't transmitted or used any tokens, haven't spent any money. And I said, the very first way or the quick way that we can interact with this chat object and the model itself is we can use functions from Elmer to chat with the model in the console. So just like it says there, live console, and then our chat object, live console. So now we have a way to chat, to interact with an LLM directly in our R console. And we can ask things like, I don't know, what color are polar bears? And we have a response. All right, let me quit this. And if I look at the object again, it's showing me my interaction history with this particular chat object. We've used this tokens in, this amount of tokens out. 2 turns because we have the interaction like as users, this was our prompt, then the assistant answers, and these are the tokens. And we could also use, as the slide says, live browser. And if we use live browser to interact with our chat object, so now we have the assistant running inside the viewer pane in RStudio. And we could keep interacting with it. What function can I use to iterate in R with a list? And we get the response from the model just streaming into our session. And it's nice and formatted, specifically when we have our code. So just one way to chat with models directly in our IDE, in this case, using OpenAI models. So let me just quit this chat. And again, this is the output without the formatting. And again, we've taken more turns and we use more tokens. At this point, basically, we're not using it, not spending any money doing this. All right. So that was Elmer. We could do more things with Elmer. There's some very cool things that we can do because Elmer has has functions to encode things like PDFs and or images, and then we just use different Elmer methods and functions to give either these images or PDFs or documents to the model, and then we can get structured output back, or get the model to describe what's in an image, or extract information from really messy unstructured text. And we can do that programmatically with Elmer. So it's something that very cool, I think, that we can use. Hopefully that worked if you tried it out. If not, you can just feel free to do it. But now let me move on to the other approach I was mentioning, which is to work with RStudio add-ins. And the first one I want to show you, or the first package that I want to mention here, is Gander, which is built on top of Elmer. And we can use that both in RStudio or in Positron if we like to. And something that I like about Gander is that every time we use it, Gander sends a snapshot of our R environment to the model so that it knows what we're talking about. Like in terms of object names or variable names, we can actually get help and actually refer to, I don't know, data frames in our environment that we want help with, or just work directly in our open script and make changes to that. So Gander is a pretty cool one that I use a lot when I'm working with RStudio. And basically, we use Elmer to specify which model will be powering the add-in. And also, Gander has a RStudio add-in, but we can also set up a keyboard shortcut for RStudio. The Gander documentation explains how to do it. But once we have our keyboard shortcut, or we just use the add-in interactively from the add-ins drop-down menu, we can just do some cool stuff with that, like I'll show you. So I have a demo script. It lives on the course website as well. It's a very silly script, but it's there if you like to see what I'll be doing quickly. So do things like this. We select which model we want to use for Gander, and it can do things like fix code. So I have some code here that doesn't seem to work because there's some problems with this ggplot2 code. And if we have Gander installed and set up, we can select it, use the RStudio add-in for Gander, and the assistant is just a very simple add-in with a text box, basically our chatbot. And we can just say things like, fix this. And we can either have it replace the selected code or add the answer before or after. Let's put it after. And it's figured out that I had the package name wrong, and I had some quotes that I didn't need, and it actually named the arguments, and it's working with the Palmer Penguins dataset from the Penguins dataset from Palmer Penguins package. So this is something that I use a lot, Gander, just like that, and it makes changes directly in our open script. All right. A similar thing that we could do is use the ChatGPT package that also has add-ins. This package was actually developed by Juan. So if you have questions about the package, he's here today. But basically, it's also another interface in R to GPT models from OpenAI. And we can also, this one I'll show you quickly. We can chat with the LLM in the viewer pane. There's an add-in for that. It's called Ask ChatGPT. And it starts a quick app right in my viewer pane where I can ask things like, what color are tigers? Or something brief like that. And we get the response back. And also there's, as you saw, there's a lot of other add-ins like pre-prompted to do specific coding tasks, like explain code or comment code and write unit tests. Very cool. And this, again, we're not leaving our RStudio to do things elsewhere. A similar package is called GPT Studio, which for in the interest of time, I'll just mention and not demonstrate. And that brings us to AI agents for RStudio. We have one called My Own Robs, again, also developed by Juan, and he'll do a demonstration for that next. And other than that, there are no agents for RStudio at this point. There's a very experimental package called Side. It's very experimental. It's meant to the author of Side is just trying things out to ultimately just sort of create AI assistant. I'll show you what that looks like very, very briefly. So it's a package called Side with a function called kick that will launch it launches an app in the viewer in RStudio. Let's see if this works. All right. So this is the sidekick assistant. And it should be working now. And I can do things like create a new version of my open script, but with lots of code comments in French. And hopefully this will work. But this is just one assistant, and the author himself, Simon Couch, was saying that he's just trying to play with things and try things out to just as a demonstration of how working with Elmer and Shiny and different things like that could ultimately build up to assistant or like a coding agent for RStudio. And as usual, is that not working when I'm trying to do a demonstration? I'll just kill it. But sometimes it works. And at some point, there will be an official RStudio AI assistant developed by Posit. This is just from hearsay that I heard at the Posit conference this year. So now I'm going to leave it up to Juan and up to him if we take a quick break right now or we just step into a quick demonstration. Let me stop my screen sharing.
Okay, I will take one from here, just for like 15 minutes, and then we can take a short break. So let me share my screen. Mm. Okay, so we are going to, can you see my screen, right? So first of all, we are going to talk about vibe coding. Vibe coding is a term invented by Andrei Karpathy, who is a co-founder of OpenAI, the ChatGPT company. So vibe coding is mostly a marketing term they invented, which means that the developer just describes a project or a task, and a large language model is going to code for it. So a lot of people thinks that this is them not coding. This is just like cheating or making it the easy way. But if we think how coding was in the start, it was like people used punch cards. This is how people used to code, just by making small holes on this kind of cards. And as we can see here, the names, it's like each function, let's say, it's like 100 of cards. So I guess that when assembler code was invented, people thought that this was not coding, this was like magic or cheating or whatever. And then the same happened when people invented C, that this was not coding, this was again just some kind of cheating or whatever. And well, until our beloved language R appeared. And again, with R, we no longer have to take care of memory management and that stuff. So it's not, I don't think that vibe coding is, again, cheating. It's something that evolves. And it's like, I think that from now on, coding will be just writing natural language code and then checking out that the generating code is working and it's something that makes sense. So there is a task from the developer that will be always check the generated code, running it and deciding if it makes what the developer really wants to do. So that's the short presentation here. So let's talk about agents in RStudio. So as Luis just shown, as the side package is meant to be an agent. The difference between agents and language models is that agents have access to the environment and your computer, but the rest of the LLMs usage as just ChatGPT is that this package has no access to the environment or whatever we have in the console, while agents do and have power to edit your code. So let's start with my own ROPs. First of all, we need to have an RStudio project. It works with projects, so let's create one. Just a typical project. So if you have installed my own ROPs as it was sent in the email, the only exported, let me enlarge the font. The only exported function we have is called my own ROPs. So once we run it, it will show you some information about the package, and you will have to log in with your Gmail account. And that's how it looks. But first, let me show just a little bit about how my own ROP works before using it. This will be presented on a talk this Friday. So let me just give a short introduction to it. So when we work with my own ROPs, the developer writes a prompt in RStudio. This prompt is sent to a server in my own ROPs. So what my own ROPs server, the backend, does is just decorating this prompt, adding some information about coding in R, and making it easier for the selected LLM to work, to reply. then the selected LLM will reply to my own robs, and it will be sent back to RStudio. If my own rob needs to iterate on the response, like asking RStudio some information about some functions or environment variables or whatever, it will execute in RStudio and send back automatically the response to my own robs, and the iteration will continue until my own robs is not requesting any more information, and the output will be shown in the chat interface or edited in the code. So should we take a break, Luis, or maybe just show like 10 minutes? Let's take a 5-minute break, and then we start using my own robs. Just if possible, if you want to test your my own robs installation or whatever, now is the moment. If you can see the chat agent here in the panel, it means it's correctly configured.
Mhm.
So yeah, let's give 8 minutes until
10 past the hour. Yeah.
8 minutes, and then we can start with some demonstration.
Okay. So see everyone at 10 past the hour.
Can you still see my screen? Right. Perfect. So first of all, let's talk a little bit about agents in RStudio. If you have been able to open your My Own Robs app, first of all, we can see here a selector for if you want to use it as an agent or if we want to use it in the ask mode. The main difference is that the agent will be able to edit your code, read your environment, and perform some edits on your RStudio project. So if you don't want your project to get changed or whatever, make sure you're using the ask mode. And then we have a model selector. For now, it just has Gemini 2.5 Flash because it's using a free API key that Google provides. So yeah, what I will recommend first when using my own robs is going to the configuration and assigning the keyboard shortcut Control M to open my own robs. In this way, we can close the add-in and then open it really fast. We have, well, I will show the other buttons later. So let's test it, my own robs in the agent mode by building a function. In this presentation, I would like to explore a dataset that is inside the Simpsons package. So if you don't have it installed, it's just doing remotes install GitHub. I will copy this right now and check if it's correct. Luis already put it in the chat. It's not needed that you install it right now, but just for you to know. As I said, this is an RStudio project. I started it with a Git version, so I can check the changes. We just have a git ignore and the rproj file. So let's start with it. So I will ask the agent about this package. I would like to explore the datasets in, well, the datasets exported by the Simpsons are package. So just hit enter, and as we can see, it's working. Hopefully it will work, not as the side package in Luis' demonstration. We can see what it is running in our our console. So this is actually running code in the console. We can see that it opens some things in our RStudio panel. We can always stop the execution if we don't like what it's executing, or if we decide to, we can cancel the running execution. So it says that it has explored the datasets in the package. If I would like to analyze any dataset, or we can ask any question. So we could ask what's in each of these datasets. Maybe we can try just like build a exploratory analysis script for the episodes data. So it's working, and as we can see, it automatically created a file. We can check again in the project that it created a new file called exploratory analysis episodes.r, and it already contains some code that we can run. As we can see, my own robes add-in runs in the viewer pane. It means that it's using the R console. It's blocked for now, so if we try to execute some code, it won't run, and that's why I recommend using the Control-M shortcut, because we can close the terminal by pressing close my own rows by pressing escape, and then we can run the code. We load the episodes. All of this is the code that my own robes built by using Gemini 2.5. We see that it did some fast exploratory analysis of the episodes. It has a summary. It has checks how many missing values. If ggplot2 is not installed, it runs it. So we can see it's a nice exploratory analysis built by AI. We can see we have some warnings, so we can iterate with my own robes. We can open it again by pressing Ctrl-M, and we can copy paste the error code, or we can even say like I run the script and it is showing many warnings. Can you fix them? While it's working, I would recommend not editing the code, because it's already in my own rob's memory. So if you are having errors with the API, with the too many requests, once I finish the demonstration, I can assign you a better API key if you send me your email. Maybe send me your email private in the chat. So, well, right now it's asking to send the correct the warnings I'm getting. So let's copy paste, make it easier for the AI. As we can see, it's reading the file. So I said that it has the power to read your files. It has the power to read your environment variables, to read your current session variables. It can edit your code. So if you don't feel that you would like an AI agent to access all of this information, you can use the ask mode. I really trust Gemini, so I use it with full power. Okay, it says it fixed the code. So let's close the agent again and run it once again. Well, we still have some warnings, but this is not the one we asked to fix. But well, this was just to demonstrate how we can iterate with the agent. So let's go a step further. Let's open again the my own ROPs, and maybe we can ask things like create a Quarto report for this exploratory analysis. And again, we can see how my own ROPs is creating new files. We have now episodes EDA report.qmd. It's still working on it. It means that it created the file, then it's doing some edits on it. Sometimes the LLMs start like iterating too many times on the same task. We can just stop the add-in, or we can wait and the LLM will mention that it's iterating for too long if we want to continue executing, or if we want to send a new prompt more specific. For now, I think we can stop it. We have already the quarter report. Let's see how it's working for now. So we have a quarter report. We can try to render. Let's see if it's working, if it looks correct. And well, we can see that the AI just created a quarter report for the exploratory analysis for this dataset. Again, we can use AI to iterate as much as we want on this task. The AI can even work to build a production ready Shiny app to explore this dataset, add some plots and a data table, a table. So we don't specify that we want it to be a data table, and add some inputs for filtering the dataset. And let's see how it works again. For some reason, it created the app.r file, but then it also created a Quarto file. I think this is because it's still working on the previous task we asked. So this is if we are switching tasks, like right now we are building a Shiny app, no longer working on the Quarto report. This is the moment where I recommend starting a new session. So the LLM will not have context about the previous tasks it was developing. So it will just focus on building the Shiny app. Anyways, the Shiny app was already built, so let's try if it's working correctly. Let me first of all restart the session. Command-Shift-0, and it restarted the session here. And let's test out the Shiny app if it's working and if it looks correct. So again, we have a similar Shiny app as in the quarter report. Now we have some filters. And again, we can iterate on it. So just give me a few seconds so I can improve the access you have so it doesn't hit anymore the API limits. So just to mention, right now it's using a shared Gemini API key, so it can hit the rate limits. But what I'm working on right now is on running my own ROPs locally by using Elmer as backend. So it will not need to send the prompts to my own ROPs server in case you don't trust the backend server I developed. So you can just use it in your computer, and I think that in the future it will also allow running my own ROPs just locally without internet connection by using Olama models. So that would be a really nice, good step. So let me check if it's. Can you check now if it's working in your machines? We all have now the same API key, so let's check if it's running. I will just ask, like, read the current file and let me know your thoughts to test if it's working or if we are hitting a rate limit. It's still working for me, so well, you let me know if it's working for you. I was thinking about giving you some time to play with it, but you can run it while I do the same task. If you No, it's okay. Let's continue. Okay, so as I said, we have many files here. Let's think about we have tested the AI to build some exploratory analysis scripts, to build a quarter report, to build a Shiny app. Let's think about building another package. So we no longer need the quarter report, and we no longer need all the generated files. Okay, no, I cannot copy the generated prompt, the prompts I use because I already created a new session and they are not saved anywhere. Just in case you don't have the Simpsons R package, you can use my ROPs to explore the empty cars dataset, the Iris dataset, the Palmer Penguins datasets, or whatever you want. It's like my own ROPs can do whatever you would like. I like thinking about AI agents as a junior level developer. So they are really, really powerful. They can do whatever you want, but they need a really good prompting. So you need to tell them exactly what you want them to do.
Juan,
See.
I think there are questions in the chat, and someone had a hand up as well.
I lowered my hand and put it on the
Okay,
Yeah, let me check. The last question I see, it's about okay, you can always, like, suppose I write the same prompt as you did. Let me restart the session. What you can try, if the agent is replying in the viewer, you can always keep chatting, like saying, okay, but do it in my code, edit my files, edit my RStudio project, and it should. So Paula, please try that one and let me know if it's working or not. And the other thing I would check is if you're in agent mode or in ask mode, you should check agent mode. Yes, please, Paula, keep trying and let me know if it's something. Maybe do you have installed the Simpsons R package? Because maybe you can tell the agent that the Simpsons is an R package. What I did to let the agent know, I used curly braces. In R, when we use curly braces, we mean, or we try to mean that it's a package and not just a simple word. So let me know if it's working. But yeah, always working with agents is iterating. It's like working with a junior developer. They are really powerful, but they need some assistance from someone who knows about the idea, the project. So Eva, about your question, if you want to nick a Quarto file that should go in the viewer pane, I'm pretty sure that if you don't close my own ROPs, then it will not render. And that's why I recommend closing the agent. And then if you want to open it again, if you have set up the Control-M shortcut, it opens really fast, and it opens in the previous session you were chatting. So that's pretty handy. Just go to the session, to the settings, and hit this button. Okay, I'm happy that it's working now, Paula. So let's go to the next task. Then we will have some time to play around with my own ROPs and all of its magic. Something I wanted to show now, it's for you to be aware of how powerful the agent is in your machine. So as I said, I no longer need the Quarto files because we are going to focus on the Shiny app. So we can run my own ROPs and say, let's start a new session because it's a new task. I no longer need any files related to the Quarto report. Please remove them. And as you will see, this is maybe a little bit creepy, but my own ROPs will be able to remove files from your computer. So I wanted to show that you must be cautious about what you are doing with AI agents, not only in my own ROPs. As we can see, it deleted files from our computer. Okay, so let's go to the next task. I would like to have an R package built by my own ROPs. So first of all, we would like to have an R function. What I would like is an R package that only exports one function that opens the Shiny app. So let's start with that task. Please build a function called Explorer. I will use backticks because we use backticks in R to make reference to function names or variable names. If we use like conventions that we use in R, it will be much easier for the agent to understand what we mean. So always it's something really needed to build good prompts. There are nice courses on building good and efficient prompts. Maybe we can link some material next and send it via email. It's called Explore Episodes App. That's the name of the function. That will open the current Shiny app. Well, it made it in a really simple way. Just it's running Shiny run app. It was not the idea, so we can iterate. Anyways, it's still working. We should always check what it is doing because sometimes it's doing things that make no sense. Like it tried to run the Shiny app and it's an AI agent, so maybe that's not the best idea. And it seems maybe it is running the Shiny app, so it might get blocked or something. Well, it's doing some edits. Who knows what Gemini is doing, but it's working. This is how agents work. They code, they iterate as regular programmers would do. But anyways, I don't like how it's just calling Shiny app, so I will stop the agent. It's that easy, and I will tell thank you because we have to thank our models, but I will prefer moving the app.r code into the new function instead of using the source command. Let's see what it does. Well, much better. Now we have a function that has all of the Shiny code inside. It's still working. Let me check what files we have right now. Something I would advise when working with AI agents is having a GitHub repo locally and always having the files as we want, not committed, but at least added. Git add, for example, I like how it looks now, the exploratory analysis. I added, so in case the AI did some changes I didn't like, I can revert those changes with the power of Git. Okay, so let's stop the work here. Let's check if it's working fine. I will restart the session. I will execute it and okay, it's running as it ran before. It's a function, so we are ready to build an R package with this function to export. But first of all, if we are using the RStudio and this project was a project and not a package, we cannot use commands like document, build, and check. So let's build a new project. File, new project, new directory. our package. The package name will be the Simpsons Explorer. Okay, so this new project has no files in it. It just has the regular R package skeleton built by RStudio. So let me open the file we had before. No. This one, right? Okay. So let's try to build a package by using my own robs. Start a new session. First of all, I will ask my own robs to read the file so it has some context about the file we want to add in our package. So read the current file, the currently open file. Well done. And let me know your thoughts, just to add some task for the agent. As I said before, it's nice how the agent works like magic, like coding for us, but it's really important for developers to read the code that the agent wrote, check if it does what we want, if it's doing it correctly, if everything looks good. Never trust the AI by itself, and that's it. So okay, it just comments what the file does. So we're ready to, okay, we say this project contains a new R package. I would like this package to have just one exported function that will be explore episodes app. Let's see if it understands that it has to copy this file into the R folder. It listed the files in this project, listed the files in the R folder. So the AI agent is inspecting our project. For some reason, it added the function we wanted into the hello.r file. That would work. It's not how I would do it, but it works. It says it used DevTools to generate the documentation. Then it read the description. It made some edits. I guess it added the required imports. No, it didn't, but it's documenting. So I guess, just guess that it will try to run document, build, and check. Let's see, or maybe it just enters an infinite loop. Now I will wait to show that if it enters an infinite loop, it will stop. My own robs will tell us that it's iterating for too long if we want to continue or if we want to refine the prompt. I usually recommend to refine the prompt if we see that the tasks that it's doing are really similar. So we can see that since our last prompt, it just run document, read file description, edit description, read namespace, and so on, doing always the same. So it asks if we want to iterate on the same. We can say, yes, continue, which is not the case right now. Right now, we would like to see what it did, if it makes sense or not. So let's close it for some time. We can see that it just edited the hello.r file. And as I said, this would be a nice moment to do git add every file, because it's mostly a skeleton and the hello.r file edited. So let's check the package if it works as we want. For now, I can see that I don't like having library called inside a package, so we can iterate later with AI. But let me document the package. Command Shift D to document. It's skipping namespace because it was manually edited. So let me remove it. Okay. Let's build it. I don't like those warnings, so that's something we can iterate with AI. And let's try to run it. It loaded the package. We can see what it is exporting, just the function we want. Let's try to run it. It's working, so at least it's working. We have another package that explores the Simpsons episodes dataset, completely built by AI. There are many things I would like to improve in this package, but at least we can see it's working, and I didn't enter any single line of code. Let's try running check. Command Shift E is the shortcut. Sorry, I'm using the shortcuts, but you can find all of the shortcuts I use in the build panel here. Okay, so now we are having some errors, and let's make the AI fix them. Oh, I am getting errors in. So if it's smart enough, it will read the description file and add the imports we need. And that's exactly what it did. And I think it's entering a loop again. So I've checked that it added the imports as I wanted. So let's just stop it. And let's go for the second task I didn't like, that it was, we'll create a new session that I don't like, that we are using library calls in Explore Episodes apps function definition. And that's it. Again, I don't like that right now it's using just import the full package. So I could ask, like, instead of using import, use import from. And yeah, you can just play around with the AI and you will see that the magic it can do. But always, as I say, like, check what it is doing, and if you like how it is doing it, and make your own edits. I mean, you need someone who knows how to code to check what the AI is really doing. And you can keep playing. You can ask the AI to add unit tests and whatever. But as we have 10 minutes left, I would prefer just to I have, okay, I can mention a little bit about the next steps in AI, but we are ending this tutorial in a few minutes. So think about if you have any questions to ask. Let me open. I would like to briefly talk about next steps in AI. So just to mention, because it's not that much related to coding in AI in RStudio, but it's something that will have some impact in the next near future. So we know that GPT-4 was released in 2023. So if we ask what is the current exchange rate of US dollars to Argentine pesos, of course, GPT won't know what would happen. I guess it will just invent some exchange rate or use the exchange rate of March 14th. So here is, what about if we could give some context to the LLM? Like if I can give a way to the LLM to access the exchange rate, like via an API or a dataset or whatever, then it will be able to know what's the exchange rate for today. And this is done by retrieval augmented generation called RAGs, and this can be integrated into R using the RagNR package. I would highly recommend taking a look at the RagNR package. It's also developed by the Deposit team by Tiders. So if the LLM knows what's the exchange rate, I could say, okay, so do some Forex magic and make me rich. But again, the LLM would say like, okay, but how would I do that? I have no power to buy or sell dollars. So what about if we could give the LLMs power to execute functions, like for instance, these example functions to buy or sell dollars? And at the moment, this is possible, and it is possible by something called Model Context Protocol. This is just a protocol that standardizes how LLMs should work with functions defined by users, and this can be done in R via MCP tools package, or even with a Elmer package by using the tools function. We have here, for example, we have Elmer, and we can define tools to assign to the chat instance. So you can take a look at the Elmer package documentation for that. It's really powerful. And just to mention that if you want to know a little bit more about MCP or connecting different functions to your LLM agents, you should check this GitHub page that has a lot of MCP servers that allow different things for your agents to access. For example, what one I like a lot is Playwright. Playwright that will allow your agent to be able to navigate websites and browsing. Okay, that was just a short example about MCP and RAGs. So let me check any questions. So Eva, if I work with sensitive data, which workflow would you recommend so the data stays only in my computer? Yeah, so if it's sensitive data, it's up to you if you trust Gemini or OpenAI or any of these. It depends on how sensitive it is. In the case it's extremely sensitive, I would recommend using local models by using Olama. This model, well, I don't know where is the documentation, but these models run locally in your computer, you can check it by just disabling Wi-Fi, and you will see that they still reply. For now, my own ROPs cannot work with Olama. I am doing some research to implement it. It will be, I mean, not because of sensitive data. It was mostly because I would like to still be able to use my own ROPs on a plane or whatever. But yeah, for those tasks, always local models are the main recommendation. They work pretty well. They are free models, so they don't have a huge developer team as OpenAI or Gemini, but that would be my recommendation. And Enrique, I'm interested in your opinion on the problem of LLMs in general. Well, Enrique is asking about how can we address potential errors that a person who does not know how to program might overlook. I would always recommend trying to have someone that at least reviews the code. If we don't, what I really like doing is some sort of cheating. I like making probably Gemini to code and then ask GPT to review the code. And if it makes some decision on the review, then I would check with Cloud Code to check the code, like doing code reviews by LLMs. That works nice, and you can like go to to checking the code by many AIs, but not allowing them to edit the code, right? What I really like is you can even create a pull request. And if you're using GitHub, it's really easy here to ask Copilot, which is an agent, to do the code review. So you just click here, and in a few minutes, you will get the code review by an AI agent. That's quite nice and handy. But well, I wish that was a good reply to your question. So I don't know if you have any further questions. Feel free to ask. You can always write to me by email. I will copy my email here. Or I guess you can also ask Luis. You can bother him too.
Yeah, for sure.
Okay, I will stop sharing so we can see our faces.
And I'll stop the recording as well.